let's talk about the quantum theory, right? And I'm going to start my notes with the heading quantum theory. And what we say, and we're talking about atoms here, is that atoms can emit or absorb electromagnetic radiation, right? This electromagnetic radiation could be anything from any one of the ranges, visible, ultraviolet, whatever, right? Or it can even be some sort of thermal or heat energy applied, where that frequency of heat energy can fall within the electromagnetic spectrum, right? But let's keep it simple at atoms absorb or emit electromagnetic radiation of a specific frequency, and on doing this, which is emitting or absorbing this energy, we say that a quantized energy change can occur. So we are looking at why these atoms are emitting energy or absorbing energy. It is because of a quantized energy change, right? I want to talk about it as at the subatomic level. So nothing moves in the nucleus. Protons and neutrons are remaining where they are. So on absorbing energy, there must be some sort of transition or movement. So we're looking at electrons moving. So we say that the electron, and I'm just referring to one electron here as my example. So we're saying the electron in an atom moves from its, and I'm going to call this, it's something called a ground state. It moves from its ground state, and I'm going to call this level E1, to a higher energy level. And we say that this corresponds to energy being absorbed. So an electron in an atom is going to move from its ground state, and I'm going to draw a little diagram here, which is just two lines, and we have E1, which is our ground state, and this ground state automatically becomes a lower energy level, versus E2, which is an excited state, a higher energy level. Right, so once again, the electron, and I'm only referring to one here for the purposes of explaining quantum theory, it moves from its ground state, right, that's its lower energy level, right, where it's comfortable, it's accustomed being there, and on absorbing energy, that electron will move from its ground state to an excited state. That excited state must be some sort of higher energy level as compared to the ground state. Now, we call this energy transition, and the energy transition I'm talking about here, I'm going to call it change in E, will be from E1 to E2, right? So this is my energy transition, the electron moving from a lower to a higher energy level. And this energy transition is what we call a quantum of energy. Now, why is it called a quantum of energy? Right? It is because electrons are said to exist in what we now know as energy levels. Energy levels, as you know, have been stated to be levels which are fixed distances from the nucleus. So we know we have the first level, the second, the third, etc. But they're all at fixed distances from the nucleus. So for an electron to go from a ground state to a high energy level, that level could be n is equal to 2, 3, 4, 5, whatever it is. We say that that transition in going from a lower to a higher level is what we call a quantum of energy. Now, in my notes, I'm talking about an electron moving from a lower to a higher energy level, but I use the term excited state, and I'm also going to state or use another term to describe it. But in this excited state, we say that the electron is unstable. Right, so I want to add in here that the unstable electron, right, will fall back down from its higher energy level back to the ground state. Right, so it falls back to a lower energy level. Right, so unstable electrons or excited electrons will fall back down to a lower energy level. Right, at higher energy levels, it is unstable. It will fall back down to a lower energy level. Right, so that means, let's say our electron went from E2 back to E1. This is also called a quantum change or a quantum of energy. Right, so I'm going to put this symbol, quantum of energy, into my diagram, and it is here. Right, I'm running out of space on my page here, but I also want to iterate why we call it, or explain why we call it quantum of energy. So from my notes, I'm just going to write it in somewhere. We say that the energy absorbed or emitted by an electron can only be done so in whole numbers or whole multiples of this quantum of energy. Right, so I'm going to write it in right here. Right, so the energy absorbed or emitted right, is in whole, well, numbers or whole multiples, right, of, well, this quantum of energy. Right, so that means if we have a quantum of energy, and I'm just calling it that little triangle with the E, right, so I want to state what this means. Right, so if we are to have an electron moving, let's say it moved to n is equal to 4, n is equal to 5, n is equal to 8, it doesn't matter. Once it moves from to higher energy levels, right, or it's dropping back down from higher energy levels back down to one lower energy level, we say that the energy change is only in multiples of this delta E, or this change in E here. So it will be in like 2, or we could have something which is 4 times the amount, right? So there's not like a fraction of an energy. This is why it's called a quantum of energy. It's a quantized energy change. It's a discrete, right? So it's a discrete amount of energy.